Hello everyone, welcome to the Class 6 of Cisco Certified Network Associate. So in the previous class we had discussed regarding IP addressing, what is IP addressing, what are the various classes of IP addresses, and what is Class A, what is Class B, what is Class N, what is Class D, what are MAC addresses, what are the difference between IP addresses and MAC addresses, and why IP addresses are only used for communication. So we have discussed lots and lots of concepts here, and we have covered mostly our IP addressing, and there is some portion of IP addressing left which I'm going to cover in this video. So let's discuss starting about classless IP addressing. So basically IP addressing can be classified into two types. One is said to be called as a classful IP addressing and other one is said to be called as your classless IP addressing. So the internet world is completely oriented with your classless IP addressing. In the internet world, in the routing world, we don't use as a class. Why we are not using class? I'll tell you, very simple. So before exactly moving into this classless IP addressing, let's revise our CIDR notation or classless inter-domain routing. So let's talk a bit about this CIDR. So as in the previous video I had already told you that CIDR or classless inter-domain routing tells the details of the total network bits in a network. Okay, so if you take an example 192, remember one thing, 192.168.0.1 is an IP address and 192.168.0.0 is the network ID, So in order to understand this, we have to move further. So while we move further, you'll understand each and everything. So CIDR tells the details regarding the total number of network bits. So let's take, we are configuring an IP address 192.168.1.19. Okay. So as it is, as according to our classless segmentation, we have the subnet mask of 255.255.255.0. So by seeing this, we can say that it's a Class C IP address, 16 bits for network, 192.168.1 is the network ID. You can't change it. You can change it only here. Here are the number of hosts. So this can be, this network, this IP address network can be written in CIDR notation as 192.168.1.19 slash the number of network bits, which becomes, so finally it becomes 192.168.1.19 slash 16, where 16 are the number of network bits. In the same way, if it's right 192, let's take 10.0.0. slash 8. So it's a Class A IP address with subnet mask of 255.255.0.0.0. So that's how we used CIDR notation theoretically in order to find what IP address or what class of IP address we're using. Now the real question arises. 10.0.0.0 slash 10. If it's 8, the subnet mask is 255.0.0.0. If it is 16 or class B, the subnet mask is 255.0.255.0.0. If it is class C or slash 16, the subnet mask is 255.255.255.0. This is slash 10 network. Okay, so this is an example of a classless IP address. A classless network. This is a classless network. Now, actually, if you take the class rules, okay, you need to write, if you apply the class rules, if you apply the class rules, you have to write 10.0.0.0 slash 8, right? You can't write 10.0.0.0/16 in classless, in classful, and you can't write 10.0.0.0/24 in classful. The reason is there is no meaning if you write like that. CADR notation, okay, in a classful networks denotes the subnet mask of it. Okay, so in a classful network, you have to write 10.0.0.0/8 because this is 10 belongs to a class A series, right? So the subnet mask is 255.0.0.0. So this 10 should be written, so this should be written as /8 only. If you write /16 and /24, it becomes a classless IP address. The class here is wrong. It's a you wrote 255.255.0.0.0, but the class rule is wrong here. So this is not a classful IP address, and this is not a classful IP address. I'll take another example. Let's write 192.168.1.0/24 and 192.168.1.0/8. So as for the class rules, we remember that 192.168.1.0 is a class C IP address, and class C IP address has a subnet mask of 255.255.255.0, which is 8 plus 8 plus 8, 24 bits. So this is a class full IP address. 192.168.1.0/8 with a subnet mask of 255.0.0. If we write this IP address as a classful IP address, it is wrong because the subnet mask of classful IP address of this 192 is 255.255.255.0 or /16, sorry, /24, but here it is /8. So this becomes a classless IP address. Okay, now 172.64.0.0/16. So this is a classful IP address, right? Because 172 is a class B address, it has a subnet mask of 255.255.0.0. So 2 octets are for network bits and 2 octets are for host bits. So this is so the CADR notation tells you regarding the network bits. So 172.16.0.0/16. So if you write this 172.64.0.0, the same network as /24, that is with the subnet mask, this is a class B IP address, you have to write a subnet mask of 255.255.0.0, but I wrote it with a subnet mask of 255.255.255.0. This is a wrong denotion of a class full IP address, and this IP address is said to be called as a classless IP address. So in classless IP addressing, the main concept is in classless IP addressing, we are not concerned about the concept of class. So the concept of the class is completely abolished or removed in this classless IP addressing. So now we'll represent how an IP address will be there. Okay, just give me a minute. So let's first write an IP address 10.0.0.1, sorry, 10.0.0.0, or we'll take in a simple manner 190 10.0.0.0/24, 10.0.0.0/24. So 10 is a class A address. We have the CADR notation as /8 and the subnet mask of 255.0.0. And by seeing this IP address, by seeing this network, we can say that it is a classless network. So now this network can be written as 10.0.0.0, okay, 255.255.255.0. This is because it is a /24 network. Now, a question does comes into our mind. Why are we using classless IP address? The simple answer I can give you for that is to prevent the wastage of IP addresses. IP addresses are costly. You have to obtain your IP address either from your ISP or INA. INA is an organization that is Internet Assigned Numbers Authority. So INA is an association that deals with the IP addressing. So if you want these IP addresses, you have to obtain either from your internet service provider or from INA. So IP addresses are costly. Now I'll tell you a scenario. You had purchased Class C IP address. Okay? Oh no, you have purchased Class A IP address of range 10.0.0.0, okay, /8. So let's think you have purchased this series. So the total number of IP addresses are 10.0.0.0 to 10.255.255.255, which gives you around 67 million IP addresses. Okay, so you have purchased these many IP addresses, but what happened? Your requirement is only 230. Okay, what happened? Your requirement is only 230 IP addresses. How many IP addresses you had? You had 67 million IP addresses. For some reason, you want only Class A IP. Remember, there is a scenario that for some reason you have to use only Class A IP addresses. So if you take this series, you have 67 million IP addresses. The disadvantage of this is cost is increased. Cost is high. Cost is very, very, very high, and wastage of IPs is there. So now what I did is I went to INA and I asked IP addresses at the range of 10.0.0.0/24. Okay, so when I take 10.0.0.0/24, it is a classless IP address. 10. Have a look carefully. 10.0.0 is your network ID, right? As the subnet mask is 255.255.255.0 because it is a /24 network, and only here, okay, you are susceptible to changes. Like only in this octet you can change, right? So what happens? The number of IP addresses, IPs of 10.0.0.0/24 are how many? 3 octets are for network ID, and last 1 octet is only for host. Last 8 bits are for 8 bits, 8 bits, 8 bits. Okay, 24 bits are for your network ID, and only this 8 bits are your hosts. Okay, so what will happen now? 24 bits for, sorry, 8 bits for hosts and 24 bits for network ID. So the total number of IP addresses are 2 to the power 8, which will give you 256 IP addresses. So what is your requirement here? Your requirement is only 230 IP addresses, right? So for the requirement of 230 30 addresses, it's better to use 10.0.0.0/24 rather than 10.0.0.0/8. So this is the reason why classless IP addressing is introduced. The main aim of this classless IP addressing is to abolish the concept of class. We don't want the concept of class. We want to totally abolish the concept of class, and we wanted to minimize. See, even in this case, we do have about 16 IP addresses wasted. But even then, okay, even then, very few amount of IP addresses wasted. The main objective of this classless IP addressing is to minimize the wastage of IP addresses. Now let's take another scenario. You purchased 172.63.0.0/16. If you take, this is a classful, because 172 is a class B, 252.250. This is a classful with a subnet mask 255.255.0.0. Okay, a 16 bits, so 8888. So 16 bits of a network, so it's written /16. So this is a classful. But you have the requirement of only 230 again, or take 250 again. So what is this 172.63.0.0, okay, /16, okay, 2 to the power number of hosts, means 2 to the power 16, which is equals to 65,536. So with the network of 172.63.0.0/16, which is a class full IP address, you have 65,536 addresses. But your requirement is again 250, very small count. So for 250 addresses, there is no need to waste. Around 63,000 addresses are wasted. So instead of opting for 172.64.0.0/16, we can take 172.64.0.0/24 with a subnet mask of 255.255.255.0. Okay, so number of hosts is 2 to the power of host bits. Okay, number of possibilities 2 to the power of 8, which will give you 256. So requirement is 250. You have 256. 6 addresses are there for your spare. So it's better to use 172.64. Both are 64s, okay? It's just my typing mistake. 172.64.0.0/24 should be used for 250 end devices or hosts or your PCs, okay? So even in this scenario, we had prevented the wastage of IP addresses. So that is the reason why this classless IP addresses came into consideration. Now, if I tell you /8, you'll write it as 255.0.255.0.0.0. If I tell you /16, you'll write it as 255.255.255.0. If I tell you /24, you'll write it as 255.255.255.0. Now, what if I tell you /10? That is a big question mark. We know how to write /8. We know how to write /16. We know how to write /24. Now, how to write this /10? Okay. So now let's take an example. 10.0.0.0/10. This is a network. So Forget about this 10.0.0.0. Now let's forget about this. Now let's see how /10 looks like. /10 means 10 bits for network and remaining for hosts, right? Even what does /24 means? /24 means even the same thing. 24 bits for network and remaining, how many remaining 8, 30 bit, right, for host. So /10 even means the same thing, 10 bits for network ID and the remaining 22 bits for host. Now let's see how /10 looks like. See, octet is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 are filled. And you have remaining 2. 1, 2. Rest of zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is how /10. 8 plus 2, 10. So this is how /10 looks like in your hexadecimal format. And if you take /20, /20 can be written in hexadecimal format as 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24. No, wait. 16, 17, 18, 19, 20. Okay? 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. So this is how you can write /20. If you observe this /10, 8 plus 10. 10 bits are for network. 10 bits for network. And how many bits for host? The remaining bits. The remaining bits are, and 22 for host. Okay. Now let's see here. 20 bits are for network. And the remaining 12 are for host. 20 bits for network and 12 are for host. Okay, got this concept? Now, let's do something. Let's take an IP address, okay? 10.192. Okay, 12.1.1.0/30. Okay, so this is a classless IP address. So 12.1.1.0, okay, /30. /30 can be written as, how will I write /30? /30 is equals to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 is 24. 25, 26, 27, 28, 29, 30. 2. Okay. So /30 network is a very small network, right? You do have all the first 30 bits for your network, right? Only 2 bits are for your host. Only 2 bits are for your hosts, right? So these 2 are your host bits. I'll separate it. So these are your come on. Oof, it's not going. So these are your host bits. So how many IP addresses can you get? 2 to the power 2, because 2 host bits, which is only 4 IPs are possible. So 12.1.1.0/8 as per a class rule has some millions of IP addresses, right? But when we want very few IP addresses, 2 or 3 IP addresses, we can take this as 12.1.1.0/30. Total are 32, right? 2 bits for hosts and 30 for network. So it will become, so number of possible IP addresses are 2 to the power 2, which is equals to 4. See how useful this classless IP addressing is. Now, okay, well and good. You had written this 12.1.1.0/30. Okay, you have taken /30 because you wanted a very small network with only 4 PCs. Okay, now what will be its subnet mask? This is a big question mark here. /30. Okay, so in order to write the subnet mask, we have to again go with this. So /30, right? How will it be there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29, 30. 1, 2. So this is how your /30 representation is. So see where are the zeros. Here are the zeros. So leave these octets. When you're here, your main aim is to write the subnet mask. So leave all these octets. Okay. Go here. I'll separate it so that it will become easy to understand. Okay. So the table goes like this: 128, 64, 32, 16, 8, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1. So this is the representation. Okay, this is the representation. So what is subnet mask? Subnet mask, as I already told you, defines the number of network and host bits, right? So this is /30. So /30 here, this is the place where network and hosts are separated. So this is the place, right? Now add all this. See, what will be subnet mask for /30? First octet is all ones full, that is 255. Second octet all full, 255. Third octet all full, 255. Come to this octet. 1, 2, 3, 4, 5, 6. Only 6 bits are filled. Add all this. 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. 240 plus 8 is 248. 248 plus 4 is 252. So the subnet mask is 255.255.255.252. We have only 4 IP addresses here, as this is a /30 network. Okay, I'll give you some other examples so that it will become very easy to understand. So what will happen? So suppose this network is 12.1.1.1.0/30. 4 IP addresses. The range is 12.1.1.1 1, 2, 3, 4 to 12.1.1.4. Sorry, 0 to 0, 1, 2, 3. 12.1.1.3. So 0, 1, 2, 3. 4 IPs. This is the range. 12.1.1.0 1.0/30. So this is the range. 4. We can give range. So 4 PCs can be connected. PC 1, you can give 12.1.1.1. For PC 2, you can give 12.1.1.2. Okay, followed by the subnet mask 255.255.255.252. 255.255.255.252. So the total number of IPs are 4. You can give it assigned to 4 devices. But remember one thing, okay? 4 IP addresses cannot be assigned. You can assign only 2. Okay, in order to discuss that, you'll understand, we'll move on further. But right now, remember that for you have to do -2 in all the cases. Okay, that is two valid IPs. Why we have to do -2? I'll tell you. Just wait for some time. Okay, let's take some other network. 192.168.1.0 slash 17 slash 17. So we know that 192.168.1.0 has a CADR notation of /24. So this is /17 and this is a classless IP address. Now let's write /17 how it looks like. Okay. First octet full 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 full. 1, 2, 3, 4, 5, 6, 7, 8. 8 full. 16 over. Plus 1, 17. Rest of all zeros. 18, 19, 20, 21, 22, 23, 24. 25, 26, 27, 28, 29, 30, 31, 32. So this is the representation for /17. Okay. Now we have to write, see here. So let's separate with this. I don't know why it's behaving like this. So these are your network bits and these are your host bits. These are your network bits. First, all ones are your network bits and last all zeros are your host bits. /17 means these 17 are your network bits and these all are your host bits. Now the number of IP addresses are how many? 2 to the power number of host bits, right? That is 2 to the power 17. These are our network bits. What are the remaining host bits? 15. 7 and 8, 15. Total makes 32, right? So 2 to the power 15. So in this network, we do have 2 to the power of 15 IP addresses. Okay? So 2 to the power of 15 is something around 32,000 like that. I don't remember. So 2 to the power of 15 IP addresses, right? Now, the challenge is now to write the subnet mask. That's very simple. Again, follow the same procedure. Okay? Where did the 0 starts? In this octet, right? The first bit is 128. 128, 64, 32, 16, 16, 8, 4, 2, 1. Remember this. First 8 octets are filled. So 255. First 8 bits are filled. So 255. Next 8 bits are filled. Another 255. Here, only one bit is filled. The value of first bit, see 1, 2, 3, 4, 5, 6, 7, 8. These 8 denotes these 8 bits. So the first bit value here 1 is 128. So 255.255.128. And the next octet is 0. So for a /17 network, we can write 192.168.1.0, 255.255.128.0. This is your subnet mask. If we want, so by using this, we can get around 30,000 addresses in class C, right? So this is how classless IP addressing and writing the subnet mask works completely. Now let's take another quick example. 10.0.0. 10.0.0.0 slash 25. So let's quickly write this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24. Add 1 extra bit, 25. 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. Okay. So this is /25. So these are 25 bits. How many bits are vacant? 7 bits. So the number of pieces that can be connected are number of PCs, 2 to the power 7. Okay, so 512 PCs. 512 PCs can be connected. Okay, so we have taken this big network. 10.0.0.0 has some 67 millions of IP addresses. If this is a classful network, this 10.0.0.0 have some 67 million of IP addresses. We have taken the 67 million of IP addresses, okay, and we have broken them. We have broken the subnet mask. We made the subnet mask /25 so that we can get only 512 PCs to be connected. So this prevents the wastage of IP addresses. Now let's write. So first 8 octets full, next 8 octets full, next 8 octets full. 255. Clear. Now here we know 128. First place is 128. What? 28. So 10.0.0.0/25 is IP address 10.0.0.0 255.255.255.128, which will give you 512 PCs. Okay, so this is how classless IP addresses are very much helpful in order to make sure that we don't waste any sorts of IP addresses. So that is the reason why these classless IP addresses are adopted in our internet world. In our internet world, we are already facing the scarcity of IP addresses, right? Already IPv4 addresses or Internet Protocol version 4 we are using is mostly coming to an end. So in this scenario, it's very important to preserve IP addresses. So this classless IP addresses, or this is also said to be called as subnetting. So this subnetting concept can be used in order to minimize the risk of IP addresses. Okay, the risk of more IP addresses to an unnecessary situation. So this is the subnet mask for this. Now I told you that you have to subtract 2. You have to subtract 2. Why? Okay, so there is a formula. Okay, total valid IPs is equals to, okay, number of possibilities minus 2 into 1 is network ID and other one is broadcast ID. Okay, so let's take a network 12.1.1.0/30. Okay, so this is 1 2 3 4 5 6 7, right, sorry 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 1 2. So this is the representation of /30. So this 128 plus 64 plus 32 plus 16 plus 8 gives you 208 plus 4 gives you 252. So the subnet mask for this is 255.255.252.0. Okay, so the entire concept of breaking this network is said to be called as subnetting. Okay, in subnetting we break a large subnetting. In subnetting we break a large IP address and make them smaller. So this is what subnetting is about. So let's take 12.1.1.0/30. So there are only 2 host bits. So the number of possibilities can be given by number of possibilities. Number of possibilities are 2 to the power 2, which is 4. So now let's write these all possibilities. We have the possibility of 12. So we have the possibilities of 12.1.1.0. We have the possibilities of 12.1.1.1, 12.1.1.2, 12.1.1.3. Okay, we do have these four possibilities, but remember a very important point in your networking. The most important thing is the first address is your network ID. The last address is your broadcast address. So the first address, that is 12.1.1.0, is your network ID, right? 12.1.1.0 is your network ID, right? And 12.1.1.3 is your broadcast ID. Network ID is used to denote the network, which network you belongs to, and broadcast ID is used in order to broadcast the network. So you can't use this in your network, as well as, I mean, this too, you can't use your network ID for your end devices, and as well as you can't use your broadcast ID also to your end devices. So this is the reason why the valid IPs are 12.1.1.1 and 12.1.1.2. This is a subnetting question. Now let's do some other subnetting question. A network is in the range of 192.168.1.0 slash 26 slash 26. Find valid hosts, broadcast ID and network ID. So in your CCNA examinations, you can find these type of questions. So network is in the range of, obviously this is a classless network, we know that. So network is in the range of 192.168.0.1.0. That's okay, leave that. Slash 26. Slash 26 means, so let's write slash 26 in hexadecimal. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 1 2 3 4 5 6. Right? So the subnet mask is 255.255.255.128 plus 128 plus 64, right? That is 255.255.255.192. This is going to be your subnet mask. Okay, for which network? So 192.168.1.0 with subnet mask of 255.255.255.192. So you came to know about the subnet mask. Now you have to find the valid hosts. So valid hosts are 1, 2. So how many bits are for host? 6 bits are for hosts. So 2 square 4, 4 2s are 8, 8 2 is 16. So it is 1, 2, 3, 2 to the power of 6. 2 square is 4, 2 cube is 8. Sorry, 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32, and 2 power 6 is 64. So 2 power, so the total number of hosts are, the total number of hosts are 2 to the power of 6, which is 64. So the network will be in the range of 192.168.1.0 to 192.168.1.63. 0 to 63 is 64. Okay, now 0 is your, so this is the first one, so this is the start of your network. So what happens here? The starting of network, where does your network start? 192.168.1.0. This is where your network starts. This is your network ID. Okay, and what is the ending? 192. the ending of the network, the ending of the network 182.168.1.63. This is your broadcast ID, and the remaining are 64 minus 2. We had subtracted the broadcast ID and as well as network ID. We got 62 valid IP addresses. So the valid IP addresses are 62 valid IP addresses. So the range of valid IP addresses are 192.168.1.1 to 192.168.1.62. So these are your 62 IP addresses which we can use. So the answers are: the network ID is 192.168.1.0, the broadcast ID is 192.168.1.63, valid IP addresses are total to the power of 6, that is 64. 64 minus broadcast ID and network ID, which is 62. So the range is from 192.168.1.1 to 192 are your valid ones. 1.0 is your network ID and 1.63 is your broadcast ID. So this is how you have to answer these questions. So I'll give you some other thing. 10.0.0.0 slash 10. 10.0.0. Why that big? Let's take slash 30. 10.0.0.0 slash 30. So you're asked the same question. There is a network in the range of 10.0.0.0 slash 30. Find the valid hosts. Okay, broadcast ID, network range, network and network. So you're asked this question. So the first thing you have to do is this first represent slash 30. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 1 2. Okay, so this is 6 bits. So 6 bits, right? 6 bits are for your network here. Okay, so that is 128 plus 64 plus 32 plus 16 plus 8 plus 4. We have taken 1 2 3 4 5 6, which is 252. So the subnet mask is first octet full, second octet full, third octet full. This is 252. So this is your subnet mask for this, right? Now let's see what happens. So now let's write this. What is the starting of the network? So the starting of, so how many hosts? Choose only. So only 2 bits are left for hosts. So possibilities are 2 to the power 2, which is equals to 4. So there are totally 4 possibilities for you, right? Now let's see what happens. So there are 4 possibilities here. So you have to subtract broadcast ID as well as network ID from this 4. Okay, that's a different picture completely. So the total so now let's see. So now let's answer these questions. The starting of the network is the starting of network is 10.0.0.0 to 10.0.0.3. 0 means the IP address are 10.0.0.0, 10.0.0.1, 10.0.0.2, 10.0.0.3. So total 4 IP addresses are there in this present scenario, right? So what is the network ID? Network ID is equals to, network ID is 10.0.0.0. The last one, what broadcast ID? It's your last one. The broadcast ID is equals to 10.0.0.3. Valid IP addresses is equals to 4 minus 2. That is 4 minus broadcast ID minus network ID. That is 2. So valid IPs is equals 10.0.0.1 and 10.0.0.2. So these are your valid IPs. So that's how we subnet. We generally subnet in order to break a very large network into a required network. If there are 65,000 IPs available in that complete network, we don't have to use all the 65,000 PCs for us. Maybe someone has some other thing. So we can take whatever we want by specifying the subnet mask. If you specify 255.255.252, which means that you want only two valid IP addresses. If you specify 255.255.255.0, you have 256 minus 2. You want only 254 valid PCs. So this is how subnetting goes. This is why subnetting is very, very, very important in networking. Now let's move on to, I hope this subnetting is clear to all. Now let's move on to what is network ID. So a network ID gives the details regarding the network. Okay, so 10.0.0.0 slash 30. So you came to know that 10.0.0 slash 30. So it gives the details regarding your network. And last octet 0 always indicates a network. Okay, 10.0.0.0 is always a network. Always a network. Last octet can't always a network. So this is the importance. And now let's see what a broadcast ID is. Broadcast ID. A broadcast, the broadcast ID, broadcast means one to all. So the purpose of this broadcast ID is to broadcast this network to all. So this is when you want to broadcast this 10.0.0 slash 30 network, you use this IP 10.0.0.3 for broadcasting. So I hope this subnetting, CID annotation, and classless IP addressing, these all are very, very clear. Remember one thing, what all the concepts that I had discussed in this video are very, very, very important. More videos are coming soon. If you like my work, kindly subscribe and share these videos. Thank you for watching my videos. This is Prithvi signing off.